Could you drop that link in the chat, actually, just so I can select it? That'll be useful if you don't mind.
Please check the chat box for the link of the agenda.
Yeah, I got it, thanks.
Hi, Rocky. It seems that the document is just is read only. I cannot edit it.
Okay, got it. Should I go? Okay, done. So maybe you can edit. So we check it. Okay, great. So now we are ready. Yeah, let's get started. Today's first agenda. We will continue discussion about the phase 1.0 use case. Arthur, can you hear me? Hello?
Yeah, we can hear you.
Yes.
Okay, so please go ahead.
Okay. Yeah, it was 2 weeks ago that we had the last call. Don't know if we should wait a bit more if someone else is joining, or that it's okay if we go ahead right now. Well, basically, we left the discussion on the phase 1.5. We present some slides 2 weeks ago that well, basically it was opening some points of discussion that they were related mainly with support of OpenConfig, but there were also some issues that they were discovered, or let's say discussed, related with the support of the OpenConfig models for the use case of this phase 1.5. So I don't know if do you have any feedback related to the open questions that we left it open a couple of weeks ago. Otherwise, maybe we can have a quick look into the questions that they were pending to be answered. So let me see if we can maybe copy and paste the questions from the previous minutes into this sheet of the current week.
Okay, thanks, please.
Yeah, I'm trying to find it. Like, let me a moment, and I will paste in the current.
Claro, entonces el tema es que parece inviable hasta el punto.
And Arturo, if it is convenient for you, I'll give you presenter role to you.
It's okay.
Okay.
Sí, yo imagino que el impacto es que se va a tener que seguir usando los NMS tradicionales, es decir, el NMS el LR8 me parece que era, y sin la visibilidad del producto de e-commerce. Mientras sea, digamos, operativo, pues...
Okay, can you see my screen?
Yes.
Okay, I think that this is the last agenda meeting that on which we put some comments. This is from 6th of June, something that it's probably the last session that we had in this use case group. So basically, there were some comments regarding the architecture and the topology exposition. So we were discussing about what it will be the requirements depending on the capabilities that they are going to be exposed to the ODTN controller. So the discussion, it was mainly focused on which is the level of topology abstraction and path computation capabilities that are going to be exposed to the ODTN controller. That this is basically what is going to define which is the interfaces that need to be selected, or the, let's say, the version of the models that need to be selected for this phase 1.5. There were some voices raising about the need to expose the optical layer details to the ODTN in order to allow the ODTN controller to provide path computation capabilities that will include the calculation or the computation of the physical impairments of the optical layer on this path computation. From Telefonica side, we were mainly saying that in our opinion, it could be positive if we could do this, okay, let's say, to reach that point iteratively or sequentially, going for a, let's say, less ambitious stage for this phase 1.5. That it will be to have a less level of exposition into the NBI of the domain controllers in order to just allowing, let's say, the selection of the endpoints with some extent to optical parameters such the frequency slot, maybe parameters related with the needed output power, and maybe receiver sensibility, in order to, let's say, reduce the complexity that need to be implemented in the ODTN controller. Because if we go directly for the model on which all the level of detail that it can be exposed through the TAPI 2.1 is available to the controller, probably the development that is needed in the ODTN controller will be much higher or much bigger, but because it needs to implement not only the, let's say, the provisioning interface of the TAPI, but also the discovery of the whole optical layer topology and the path computation with these physical impairments. I think that the discussion were mostly there. I remember, and I have noted that it was pending from my side to include a, let's say, a diagram on which it could be reflected the use case to expose, let's say, the media layer topology. But this is something that unfortunately I couldn't achieve. Maybe some of you knows that we are currently involved on the OEF activity with the Transport API 2.0 interoperability test and also other tests in the lab. So it has been a very busy period. So I apologize for not having this material ready, but I will try to compose it for later sections. I don't know if at this point there is someone in the call that I would like to let's say comment something regarding this discussion that we had 2 weeks ago. So I think that mostly I summarized which were the discussion, which are the two approaches that they were proposed, and I don't know if someone else has something else that it was pending to be discussed, or any other issue that it was discussed in the previous call that it has been not properly expressed by myself right now. Okay, then I think that at this point there should be
I'm sorry,
a decision.
Arturo.
Yes.
I'm sorry. I was double muted there, so pardon the delay.
Okay.
So the last time we were discussing exactly where or possible ways of where to put the path computation, and I think there was the issue that if it could either all be done in the OLS, which is one point of view. I think there was some pushback on that incorporating that kind of feature or capability, you need to have an OLS that supports that. The alternative, one alternative to that is to have a simplified view. If you go to the other extreme, have half the computation done in the ODTN controller, then it would require knowledge, having to incorporate, as you were saying, the power control information, the impairment information, and exposing all that from the OLS up to the controller. And so that's a lot of information. Would require extension of TAPI to do that on the southbound side, that we've been talking about. So an alternative would be to have a simplified path computation done. You use the topology discovery service through TAPI on the southbound side, find out the basic abstractions like option A, but have a simplistic non-impairment or non-power controlled version of path computation done, but not just one path, a multiple set of paths being done, and then those paths kind of being passed down one at a time, to the OLS. And then the OLS can check and see which one of those is viable, and you can have some algorithm. I mean, this is a simplistic approach. Have some algorithm that would then basically select, the first one perhaps, and then the first one, first come first serve, first one that is viable, and then that is the resulting path that gets provisioned. This of course would be slow. It would not be optimal in terms of spectrum utilization, since it's basically a greedy approach to allocating a path hop by hop at the optical layer. But nevertheless, it would at least accomplish the goal of avoiding some of the modifications to TAPI, the extensions to TAPI required to communicate extensively to the ODTN controller. It would avoid detailed development of a path computation engine in the ODTN controller itself, having to take into account power and impairment information. Again, this is predicated on the assumption that the OLS does not support path computation, so this would be a way forward with that. But the price here is that the resulting utilization of the network is going to be suboptimal, and probably features of the transponders themselves it's going to be basic. Like, you have to make some basic assumptions, like operating off of an ITU, one of the ITU grids, no flex channel width, or some standard modulation schemes, making assumptions like that. Just it's a standard grid, the usual some of the range of modulation schemes, and probably knowing the power range capability of the transponders. It would be like basic information there, and that information then in turn is passed down to the OLS controller through the TAPI southbound interface, so that the resulting provisioning can be done. Spectrum management would need to be done in the ODTN control, so it at least knows what channels can be used, or it could just be a service request to the OLS, and the OLS can come back with, okay, if this is your path, then use these frequencies. But then the OLS controller needs to know what the capabilities of the transponders are. So there's some details to work out there, sort of chicken egg problem a little bit. But that would be an approach, and I think it's more of a simplified approach, not an optimal approach, but it is a simplified approach, at least in terms of getting started on being able to perform path computation at a simplistic level and not requiring too many extensions to TAPI. So was that clear?
Yeah, I fully agree with you. I think that this approach is reasonable. Let's say that just to clarify, I think that it's not well. We need this to be confirmed by Karthik, that is the expert on TAPI. I understood that from the latest presentation you did, TAPI version 2.1 is going to account for many of these physical impairment model needs that they will, let's say, be relevant if we go for the model of having ODTN controller making this path computation with the physical impairment constraints. But I think that the main problem also is, and it is something related with what I saw on the development on ONOS itself, is that we are going quite slow. We don't have a lot of manpower dedicated on developing on top of ODTN on ONOS controller, let's say, and also for a realistic point of view, if we take some months in order to implement phase 1.0 use case, that it was basically to make an on-off transponder configuration, not really that much, making the effort on developing the path computation, this topology discovery, only if we go for a logical topology discovery on which we just will discover which is the topology, which is the, maybe we can go just for the spectrum state of the network. Just with that, it is a considerable amount of effort on development on ONOS, and this is plus configuring also the transponder part that we didn't take into account, that it will be necessary also to configure the lambda. We need to account for the power configuration, and probably if we go for a realistic, let's say, use case, we will need also the configuration of some sort of logical assignment between the client ports and the optical line ports. So all of this is tasks that need to be done by the controller, and this is just assuming for a logical topology exposure and this simplistic use case that Gary has mentioned right now. And for me, I think that it is enough for phase 1.5. We could maybe discuss here what is going to be the scope for phase 2.0 in order to not, let's say, left the effort remaining on this just simplistic approach. We can also work on defining which is going to be the scope for the next phase. But from a project management point of view, I think that this is something considerable for one iteration. I don't know if other has a different opinion than me, or if you consider that maybe going for this, let's say, abstract approach or simplistic approach of path computation only on a logical topology view of the open line system domain is going to preclude later steps towards more, I don't know, desirable architectures or features acquired by the ODTN controller. In my opinion, no. In my opinion, this should be this could be a sequentially approach. I think that there are features that need to be implemented anyhow, but this is the path computation just on a topological level, and the configuration of the transponders. It is, of course, something that it is not fulfilling all the expectation, but I think that is some in term that it could be enough for this phase.
So Arturo, this is Karthik. I agree with you that it's better to go step by step, right? It's better chance of us achieving something. But yes, you're also right that TAPI 2.1, we are looking at quite a lot of details. And actually, like Nigel, for example, is looking at analyzing both the open rotor model. We have some Stefan who's looking at the like TIP, and we are analyzing some other models, and we're trying to sort of align and merge all of the information from all of those models. So it's taking more time on this open line system side if you want to expose the detailed topology. The physical impairments, for example, we may not have everything that we need, or we may have more than we need. I don't know the output of TAPI, but it's definitely better from ONOS side that we take one step, like intermediate step, before we get there. That will also give some time in TAPI to align with, say, for us to analyze even the existing industry models.
Right. That's right.
And that's what we are trying to do right now. And there's a lot of debate going on, like, well, how should we model the open line system topology?
Yeah.
Not so much on the information, but what kind of model should it be doing in TAPI? So it may take some time for us to converge.
I think maybe just to be a critical clarification there, Karthik. I think we, from the perspective of the model, it's all about the level at which we represent media channels. We know how to represent them. It's how many, whether there's multiple levels of media channel representation or not, and so on. So there's a complication there which has been causing us some. I'd say I'd be pulling my hair up, but I haven't got any. So on that basis, I'm not. But and the other thing is the specific detailed measures. There's quite a lot of overlap in the, but not complete overlap in the specifications in Open Device, Open ROADM, Open Config, IGT, etc. of the properties. We know where we would put them, but we just don't know what the properties, the specific set are. And as Karthik said, we may have an overkill of properties by the time we've finished. So measures and settings, which is beyond where you need to for this level of disaggregation. So that's the other challenge. But we don't want to miss any. So of course you have to be fairly diligent, and there's quite a lot to wade through. Where after a bit of wading, you find the same thing again. You think, oh, is that all that's down there? It's the same stuff I already found in the other document, or it's got a different name on it, or they seem to have a smaller range of capability with that thing. But so that's the challenge is media channel. The degree of media channel recursion and the specific details of the properties rather than where we put them. I think we know where to put them when we find them. But does that make sense, Karthik, as a clarification?
Right, yeah.
Okay.
Just I'll ask if there is questions from someone else. Yeah.
And I would add, even having the information, which is a good thing generally, is one thing, but then using the information is quite another. So that means
that's right.
Even if all the detailed exposed information is made available, then an algorithm has to be developed or a capability has to be developed for actually leveraging that information to compute paths.
That's right. That's
so
right. And
there's another level to that after that. Yeah.
Yes. And of course, I mean, it could be a matter, again, back to Karthik's point, a matter of degrees. Although the information may be available, you may not choose to use it immediately. And we get some basic paths, as was suggested before. I think that makes sense. And then as the greater level of sophistication in the algorithms emerges, or we recognize a need for greater sophistication in the algorithms because the paths are significantly degraded in some way or other, then of course that work will happen. So I think taking first, a few steps first, getting more information.
Yeah, right.
Parallel.
Roger that, because I was just going to say, if you have an OLS that is capable of computing a path, then problem solved. If you don't, then some sort of capability is going to have to be developed there, and doing sort of the approach we're talking about now, which is sort of a basic approach, which is really a logical path computation, and then polling the OLS to see which of these paths might actually work. That actually provides a placeholder for path computation engine development within ODTN in the future. So I don't think it precludes that. So to address Arturo's question, that does the simplified kind of incremental approach sort of paint you into a corner? I don't think it does. I think if the ODTN controller level path computation can be bypassed if the OLS supports it, and if not, then there is a way around that, either at a simple logical level or and leaves the door open for further development later on.
I think I'd agree with that, and it may be that you may find a situation where as we advance through more complex topologies, etc., and that certain path computation algorithms work well with one particular set of topologies, and other ones work well with others, with with the right balance of data and so on, and you may end up with a couple of different algorithms for different cases, and then sometimes you're in the middle and you have to go and poll both, and etc. There's all sorts of but none of that's blocked by doing a first step or a second step of basic capability at all, because as long as you make them swap in, swap outable, then and you can run several and so on, then I think there's no issue.
Agreed.
That's it seems that we are pretty much aligned, and I wanted to introduce another element here on the architecture that we are proposing and we are relying on. There is a fundamental component that is the open line system controller that we didn't discuss so much about it. This is, I mean, it's not only the TAPI that need to be ready to expose the necessary information to make this use case visible. It is not only the ODTN controller need to implement it in order to be able to make this path computation with physical impairments and so on, but also the open line system controller need to expose this information. And we didn't discuss about that. We don't really know which is the support of this or which is going to be the roadmap for the open line system controllers in order to expose this information. So, well, in my opinion, as I see how it is the support of TAPI right now that we saw in this OIF interop event, we saw that TAPI 2.0 is ready. There are several implementations, several suppliers that they have implemented TAPI 2.0 with a very rich set of functionalities that are there. I think that this is, well, a reality that it can be fulfilling our needs on the open line system controller. But I don't hear, and well, it is normal because it's not even yet defined, the support of the open line system controllers for TAPI 2.1. Then, well, this is another element that I think that it should be taken into account in order to decide to go a little bit slowly with this. Well, I think that this is a fundamental decision that we should make now. I don't know if you consider that it could be worth to make a, let's sort of doodle or let's say request to everyone participating on this activity in order to find an agreement on the architecture and the level of exposition and so on. I have, well, maybe you have it in front of me, these 4 options that I consider that are the ones that it has been discussed. Maybe we could pull for votes of all participants here in order to have an agreement on which is the direction that we should follow, and based on that, start going into the details based on the architecture and topology exposition that we are deciding. I don't know if other organizers, Yuta, Hiroki, do you have any comment on this? Do you think that is a good approach to make this polling request in order to understand which is the vision of everyone, or which is the majority option that it will be, let's say, desired or accepted by everyone?
From analytical viewpoint and simplicity and some kind of agile way is much better, and we should select some way like option A, and we should hide some open system controllers path computation features, and it is a better way that the open system controller expose this information to the ODTN controller. But I don't know. You know, open system controller will expose this information and support these path computation features. So at the first step, we can assume these something open system controllers will support these path computation features, but we should consider if open system controller doesn't support the path computation features, and we have to implement this path computation into ODTN controller, then we have to do the open system controller domains path computation and global domain path computation. We have to both of the path computation in the ODTN controller if open system controller will not support path computation feature of the open system domain.
Okay, so you mean that in your opinion the best option it will be option A if the open system controller is able to perform path computation within its domain. This is correct?
Yes, exactly, yeah.
Okay, I think that it could be possible. I think that it has been discussed also to allow to expose the open system controller an abstracted view of the media layer topology in order to make the path computation at an abstracted level in the ODTN. So in my opinion, the discussion or the election will be between this option A, option B, that it will be not introducing any level of detail regarding the media layer, and the option C, that it will be to expose only some part of the media layer, like for instance, information about the frequency, the spectrum that is occupied in the network in order to allow the ODTN controller to make sort of routing and spectrum allocation. Karthik, I have a question. I wrote here which will be the necessary TAPI version. Do you think that option C, it is enabled with TAPI 2.0 only with the OTSI model that is currently available, or it will be needed some extensions of the TAPI 2.1?
You need 2.1. So I would say like you'll need 2.1. And even for option A, if you're doing it like I'll have to make and release 2.0.4 or something for option A. Because what we have to do is while we're actually looking at the media, we have not changed the OTSI layer much, but we have added some flexibility into the OTSI layer, like more information. So even for option A, I would say like you should use like the latest draft, whichever is possible. But definitely for option C, you have to use 2.1.
I will just say, I do agree that we should go for the latest versions of TAPI. This is for me out of discussion. I will just say I will just try to, let's say, sort the different options based on if they are implemented or not with the current version of TAPI that is available. If it is feasible to go for option A with the current version, I will just put the current version, because this is somehow a way to understand also which is the complexity that need to be implemented. Even if it at the end we will go for the latest version, but if we can assume that this architecture or this election can be done with the TAPI 2.0.2, I will just keep it that in order to have a more clear vision about it.
Yeah, let me try to, So Atul, just let me try to clarify a little bit why I meant, right? In 2.02, there are no SIPs or connectivity service endpoints defined for OTSI layer, right? So right now, because that was like in early stages, so we at least need to add those two extensions, right, for the SIP and CSEP, right, to be able to create OTSI connectivity. So that's what I meant. Like, either I create a 2.04, right, so you don't have to use everything that's in 2.1, with at least those extensions necessary.
Just one question. The TAPI version that we are currently using in the OEF interop event is TAPI 2.0.2, right?
Yes, but that is, you are using that, but we are not doing that for OTSI, right? So that's the problem.
No, that's correct. But for instance, option A for me, just to so we can discuss, we can complete this definition. It's just option A for me is you have completely abstracted the topology and the media layer information. You just select the service endpoints, and you don't have even the possibility to choose which is the wavelength. I mean, you don't have any visibility. You
don't have OTSI layer specific attributes. Okay.
Exactly.
I got it.
The option B, it will be you have visibility about the topology, but even it is not needed to. Or in my opinion, we can maybe exclude this option B. But what I want trying to put here is that the position of the topology is not augmented by the OTSI model. So you just have the visibility about the logical topology. You know which are the nodes. Or maybe you have the maybe you have the augmentation of the media layers, but just an abstracted view. I mean, you don't have even the information related the frequency or the media layer physical model. And the option C, it will be with some extensions that probably you are taking into account now in the TAPI 2.1. Do you think it's clear? Do you think that I should include more information? Maybe I should just try to put all this information in the current, let's say, sheet of the today agenda. So anyone that wants to contribute, it's able to. So is this one? Comments. Okay.
Vale, pues bueno, pues más o menos lo único, la parte del gesto de la queda claro.
Okay.
Y la parte de la
feel free to complete or to add any comment or any information that it has been discussed in the call. Okay, I think that we can. Well, how do you think that it will be the best way? Sorry, go ahead.
Well, I was just, your question, I thought, regarded that last bullet you have on the screen there about the the OLS controller, and I thought your question essentially was, where was the OLS controller going to come from, because the development for it is not included, was not included as yet in the project, and so either it has to be developed or it has to be provided with an appropriate interface. It seems like those are the two options, really, right? So if we take one that, you know, from someone, then it has to be able to communicate with the ODTN controller according to whatever all the requirements. So that would require development on the part of an existing OLS, because I'm sure it doesn't support TAPI 2.01, 2.1 or 2.02. You know, that's because I'm sure it's in development right now. But so I guess that's the question, right? Where does the OLS come from? And if you were to expose everything from the OLS that's needed, then that's essentially developing path computation, detailed path computation in the controller. Otherwise, the OLS controller has to provide some level of checking whether, you know, point-to-point connections can work, and but it still has to be able to communicate through a TAPI interface. So what is the current, if OLS controller is not developed as part of the project, then what would be the assumption about where the OLS controller comes from that can provide the services in the right form?
Actually, it's a good question. I see two options. Okay, I mean, we could directly ask if any provider is interested on supplying an implementation of a TAPI server that it is exposing the level of details regarding the architecture that we are choosing for this ODTN project. Assuming that this is going to be, let's say, standard and is going to be open on the implementation that is provided on the NDI, we assume that to some extent the details of the internal management of the devices is not going to be exposed, but at least you need to be, or we need at least an implementation or a supplier that is able to provide an open access to which is the details of the implementation of the TAPI, which are the services that how are they exposed, how is the topology exposed, and also to be pretty involved in the activity in order to provide that. Another alternative, it will be, and this is somehow a little bit less, I don't know how to say. Well, my idea was that with SDN, what I have seen in the past is that basically every controller can be recursive. No, you can use ODTN as the open line system controller, and the only problem here is that you don't have maybe implemented the SBI and the management of the devices. Then the range of not the range. Let's say that all the features that you can expose with that controller will be somehow fake because you don't have real hardware beneath. But at least you could use it as the open line system controller in terms of that is going to be implementing the exposition of the topology. Maybe it can even expose the topology service. And it is something that is going to be also useful because to some extent, the ODTN controller will expose an NDI that it will be used eventually by client applications. So probably you can reuse that effort that you are doing on developing the NDI of TAPI in the ODTN controller to reuse that controller as open line system controller, assuming that you are going to have somehow a data plane. I don't know how to say, let's say fake or not implemented, and maybe you have some configuration pre-created on the controller, and based on that it is able to expose all the information that it will be necessary to implement the use cases on top of it. Assuming that in real proof of concepts you are going to not using this fake controller, but you will have real open line system controller that will expose the same functionalities that you are exposing with this fake open ODTN controller. I don't know if this makes sense to you, but this is something that I already used before in developments in order to speed up the implementation.
Okay, well, let me ask this then. Maybe a different way of asking a related question. I mean, I think I got most of what you were saying, but let me just ask it this way. So for the purposes of this project here, in the operator networks where the testing will be done, in the test networks, do we have an understanding of what the capabilities are of the OLS systems that are present there?
For sure, this is something that need to be defined. What I saw, for instance, for this OEF activities, that you can present a document with a TAPI specification, which you are describing which are the capabilities of the TAPI interface that are mandatory to be implemented by the controller, and based on that, you have a reference document on which you can rely on related to, I mean, regarding to make an implementation on top of it.
Okay, because it just seems like the OLS controller is kind of like going to become a major effort if unless we make some assumptions and have some already kind of, I don't want to say built-in capabilities, but some capabilities. Otherwise, we're gonna have to spend a certain amount of effort to get the controller to do a certain amount of computation that is very detailed and very physical. And so I guess the alternative would be to have OLSs in place that are basically providing minimal information about from a physical layer, but it's only requiring enough so that a service request could be passed down to the OLS from the ODTN controller with, you know, a collection of points, a collection of connections that need to be made in order to realize an end-to-end service. And then the OLS can see if that's possible or not. I don't know. It just seems like I feel like there's a certain, from a project management perspective that you're referring to, that, you know, I think that this has to be defined a little bit more specifically, because the concern is that it could lead to a lot of open-ended effort and delay us more. That's where this concern is coming from. It's like, how can we manage to go forward without delaying, without incurring too much delay here? And I think it centers around the OLS system, right? Yeah.
I do understand, but well, I agree, but I mean, if we can define which is the level of exposition that we want on top of the open line system controller, we will be able to, let's say, define this concretely in a reference document in order to request that to the providers community, in order to understand which is the support that it can be delivered on that. It is true that, as you mentioned, maybe reduced complexity can be assumed that is going to be provided by the open line system controller, but this is what I was mentioning before. We cannot assume a very, very high level of exposition in terms of physical impairments or level of detail of the optical layer right now, because well, I think that this kind of development is still at a very early stage. So I think that if we are a little bit conservative on defining what it is expected regarding TAPI and BI, we will be able to let's say, have some vendors interested in participating, as we are seeing from the perspective of the open terminals. We also have, now we are relying on the vendors implementation of the open terminal interfaces in order to make this activity going through. The same is going to occur, let's say, with the open line system. And the discussion here is, I think, which is going to be the steps in order to achieve this as fast as possible. I mean, my doubt is, imagine that, okay, you are introducing a discussion, an open point of discussion that is, it is not going to introduce a lot of complexity to introduce the open line system controller in the equation. What if we go directly to configure the open line system devices, let's say? if we go like that, we also will need to rely on implementation of the let's say open models for RODAMs, for WSS, for amplifiers and so on of the vendors, and we will also need that support of the industry in order to achieve this. I don't know if you have a different perception of me, but I think that there is not a lot of let's say or it is not really mature the development of this sort of models for the open line system devices, and I think that we will face a similar situation on which we will need for sure to depend on the implementation of these models by some suppliers. I don't know if do you think that it makes sense or not?
From
Sorry, go ahead.
Ecom perspective, the option you mentioned, which configure open system devices directory, is not good option because it is if we choose this option, we can deal with all things by ourselves, but it is not. I think there are no feasibility to implement these features into ODTN controller, and it become too complex, and we can't implement these features in ONOS ODTN, and we should delegate this open client system powered simulation, maybe if possible path computation, and decouple these features with global domain path computation and something like open system path computation, power simulation features. So I don't think it is we should not choose this option.
Okay, I do agree. Telefonica, we have the same opinion. We see a little bit far and complex to go for this option D, on which you rely on open models for the RODAM components, and we believe more on a short-term approach on which we will use an open line system controller that is exposed in TAPI. And regarding the level of exposition of the capabilities, we can, I mean, from our side, the requirements, we are not going to say that they are few, but we could rely on path computation entirely done by the open line system controller. We don't have a problem about that. We will just need maybe to assure that you can select some parameters on the service endpoints related to the optical layer. I remember that we mentioned it the other day, and this is maybe the use case that it will driven all of this. That is that you have multiple domains and you want to make through to create an alien wavelength service through the two domains on which you need to configure the same wavelength on the two domains of the two media channels. That use case for sure has some constraints in terms of let's say distance that it can be recovered and so on, because if you don't have a completely exposed physical impairment model, you for sure you're not going to achieve the best performance or the best distant range that it can be achieved if you have this information. So this, I think that it will be the sort of limitations that we should identify and we should state, and we say, okay, we go for this architecture, but we are assuming that listing some of the constraints that Gary has mentioned it before, you will have sequential service provisioning or path computation, because you will not be able to guarantee or to perform multiple path computations or multiple service provisioning at once. You will have also these limitations on terms of the performance that the equipment is going to provide you, because you will assume, or you will need to constrain maybe the paths that you are setting up for the media channels to a, let's say, conservative range, in order to assure that you will have a good quality of transmission for a given transmission format. But based on that assumption, you will be able to have, let's say, an operational architecture that I think will fulfill most of the expectations that from the operator from the operator's point of view we have. I think that yes, this is I think our perspective. I think that Hiroki, you will mention mostly the same than me. I think that we are mostly aligned on this. So probably we will need just to go for the let's say for the decision of going through the three first alternatives for this phase 1.5. So in principle, I will discard option D from the equation, and we will just focus on identify which is the level of exposition of the TAPI models that the open-line system controller need to provide. I don't know. Maybe this is something that we will need to request. Coming back to the previous question, so which will be the way to involve an open-line system controller on the project? Because this seems completely necessary for going in this direction. There are not a lot of suppliers today in the call, but so I see people from Nokia that maybe, I don't know if it will be a good idea to directly ask you if you will be interested in providing an implementation and work together into the definition of which is the level of exposition that it need to be, let's say, requested to the open-line system controller in order to move forward.
Yeah. So okay, so I can speak briefly to that, Arturo. So I'm from Bell Labs, the research branch of Nokia.
Okay.
And I do need, so what we can do is I can take that as an action item to discuss it with our BU. So, there is a way forward using option A, and then option C, I see a way forward as well, which is, as I was saying, that you do some sort of topological path computation, and then you iterate with some kind of OLS controller to check for feasibility until you find one. But in either case,